Hello, welcome to our presentation. We are Group 48, focusing on creating a sterilizer for low-middle income countries for instruments used in childbirth. I am Lauren Brown from University of Massachusetts Amherst, joined by Jade Montero from University of Florida, Isosa Agbe from Cornell University, and Natalia Alonso from Boston University. While creating a design for our clients, we found that there is a need for a design for a low-cost sterilizer in low-middle income countries for instruments used in childbirth. We chose to base our clients in the West African region, which has a large rural population and does not have the same access to medical facilities that more developed countries and regions have. Some specifications for our sterilizer are that it needs to be able to sterilize metal instruments used in childbirth that may be used to assist the birthing process. It needs to be relatively low cost and easily reproducible for broader accessibility. It is common in West Africa to give birth at home under the care of midwives and family members, which meant that our design should be portable, and due to the lack of consistent electricity in this region, it needs to be operated independently from stable electricity.
In order to effectively address and refine our client statement, we conducted background research which informed any choices we made to narrow the scope of our project. As mentioned, these choices included limiting the design to the sanitization of metal instruments and making our target demographic West African midwives and/or traditional birthing assistants. These decisions were made based on societal and cultural research in order to be mindful of differences in birthing customs and an attempt to create a product that is as convenient as it is effective. These factors heavily influenced how we approached this project, and with these restrictions in mind, we were able to head into the design process with a little more clarity.
From there, we determined the functions our product must be able to carry out and then selected the specific means for each function. We initially focused on traditional steam autoclaves, which sterilize instruments using steam and pressure. However, we found that this design was often too costly as well as too large for midwives or skilled birthing attendants to rely on. Thus, we came to our two-part design.
Here, we look at a standard dry heat autoclave made from stainless steel, a metal that is reasonably cheap and produces much structural integrity against heat and the other elements. Upon closer inspection of the upper compartment, we see the wonder of efficient sterilization with heating coils that increase temperature to effectively kill bacteria and disease-causing biomes. The lower compartment contains a cooling system to allow immediate collection after processing. By the side, we see a control system to regulate temperature and track processing time. Behind the machine is a highly efficient battery compartment that stores energy to offset scarcity of electricity and other power sources. Finally, 3 racks inside the autoclave increase machine capacity to sterilize high counts of objects per processing time. To increase efficiency of the sterilization process, a portable UV sterilizing box is an important addition to store sterilized objects for future use. Powered by 5 powerful and replaceable UV light bulbs, this box ensures enhanced storage and availability of sterilized objects. In places where traveling midwives are heavily involved in childbirth, such as West Africa, this portable storage box can serve as a useful piece in medical practices.